protect the climate, we're changing in ways that might surprise you. We've turned to the most experienced fluid dynamics experts in the world to make airplanes more efficient. We're planning a heat pump the size of a soccer field to reduce our own emissions, blazing a trail with recycling technology to breathe new life into old electric vehicle batteries, and to power our own factories. We're building an offshore wind farm, the biggest in the world. To protect the climate, we're changing, getting inspiration from all kinds of places and all kinds of people.
Hello, everyone. Welcome to our Sustainable by Design event series. My name is Ben Glavatsky. I'm the Sustainable Business Strategy Manager at BASF, and I will be your host for these event series. Thank you all for joining us today. We appreciate your time and the time that you're dedicating to sustainability and to our efforts here. Sustainable by Design is an event series that we are hosting during this month of April to bring sustainability awareness to the forefront. We want sustainability to be at the design phase of whatever product or service is brought to market. So in essence, let's design with the end in mind. We have a total of 8 one-hour sessions over the course of the next 2 weeks. That's this week and next week. The topics vary from plastic circularity to agriculture and just about everything in between. As you can see, we will run, let me move the slide over. We will run 2 sessions per day. So we have an afternoon session, a morning session and an afternoon session, and that will be on all 4 days. Today we have our BASF Welcome, followed by a Fireside chat hosted by our Venture Capital Group. This afternoon we have our session on climate resiliency through agriculture, coming to you live from the BASF Center for Sustainable Agriculture in North Carolina. So just some final comments before we get started, some housekeeping items. On the right-hand side of your console, you will see speaker information. So you'll see some information about the speakers, you'll see some headshots, so please check that out. And there's also a box just below that on resources. So we've put some additional resources into that box. Some of them are simply just links to websites. In other cases, we have some downloadable content, so please take a look there. We do have a place where you can ask your questions. We do have limited amount of time, but we will do our best to answer as many questions as we can during this event. And for those that we can't, we'll answer those afterwards. Also, very important, we do have a survey. So there are some boxes at the bottom of your console. On the very right-hand side, there's going to be the survey. Please click on that and give us some feedback. We very much appreciate it. So once again, thank you for joining us today. And now I'd like to introduce Tobias Straat, President, Region North America, BASF. Over to you, Tobias.
Thank you, Ben. And well, it's a great pleasure for me to help kicking that off. And I'm truly excited also seeing all the energy you contribute here as contributors and participants to this week's and next week's program. Well, chemistry is our passion, and at BASF we create chemistry, and that we have been doing successfully for more than 150 years. But also back in the year 2011, we incorporated "We create chemistry for a sustainable future" as part of our mission statement. So that's one way to showcase our long-term commitment to sustainability. We as BASF want to be the most attractive partner for our customers to overcome challenges that we believe can be solved with chemistry. Well, our customers are at the center of everything we do, and often we do that by leveraging on our products, technology, our innovation and entrepreneurial spirit, and of course also our big integrated Verbund structures. But you will also hear from BASF Venture Capital Group, along with Breakthrough Energy Ventures today, about investments in young, early-stage startup companies who develop novel technologies and disruptive business models. Speaking about emission targets, just move here. Compared with our 2018 baseline, we want to reduce greenhouse gas emissions from our production sites and our energy purchases by 25% by the year 2030. That means translated in greenhouse gas emissions, a reduction from close to 22 million metric tons to 16.5 million metric tons. And that's despite our growth plans and the construction, for example, of a new Verbund site in southern China. Altogether, a decrease of 60% compared to our baseline back in the year 1990. Our long-term goal is net zero by 2050. Our Geismar Verbund site will host a session to talk about Louisiana's energy transformation and carbon capture as an opportunity. We are intensively pursuing our climate protection targets and also put the money behind where needed. And we want to play an active and responsible role in shaping the transformation toward a climate neutral society. On a very high level, we do that via 5 strategic levers. One is gray to green energy conversion. Then it's about power to steam as a lever to convert. It's about continuous OPEX as a lever. And I just mentioned where we had been coming from back in the years of 1990. And we do it with bio-based raw materials and obviously also production processes which allow nearly carbon-free production of chemicals. Visualizing that on 2 perspectives, actually, on how we set targets, we do that or achieve that in 2 ways. One is reduction measures at the site level to reduce overall Scope 1 and Scope 2 emissions with our own carbon dioxide emissions. Combine that with reductions in upstream Scope 3 emissions and the work that we are doing with our suppliers that will ultimately allow our customers to receive reduced product carbon footprints. Our strategy supports our climate targets and our products will support the climate targets of our customers. And we provide also our customers specific transparency on the product carbon footprint. We are deliberate about targets rather than just going out with ambitions. So we do that step by step. That's why you, for example, don't see a Scope 3 target right now. For sure, it will come, but it requires a lot of engagement with our supplier base. Now, framing here a little bit what is to come, which Ben briefly outlined in the prior slide. One bigger theme, biodiversity. Our session this afternoon will be on climate resilience through agriculture, presented by our agricultural solutions segment. This session will address how science and innovation are enabling farmers to make the most of their land to be as effective and efficient as possible and how to use regenerative farming to help climate resilience. The panelists will discuss the importance of diverse soil, microbiome communities, improvements to crop yield and yield traits to conserve resources. They will share what best practices in sustainable agriculture looks like today and what it may look like in the future, as determined also by scientific data. Please tune into that session if you're interested in this important topic. Next up, responsible sourcing. Some of our other sessions will talk about responsible sourcing and the importance of partnership in the entire value chain. We have, for example, an initiative from BASF Mexico that aims to improve small coffee producers' quality of life using technologies that enhance both yield and quality while preserving cultural heritage. Further, BASF, along with Estée Lauder companies and the Roundtable on Sustainable Palm Oil, are partnering with the civil society organization Solidaridad to promote sustainable palm oil and palm derivatives production in Indonesia. Next, as a big theme, circular economy. We are working to develop circular economy models to reduce resource consumption and to reuse existing resources as much as possible. You will hear about the work Canada is doing with ResiChain and how that program supports plastics circularity in the value chain. This is a specific technology cloud-based ecosystem to enable tracking, tracing, and sorting recycled materials, actually by leveraging blockchain and other technologies. So consumer packaged goods present obviously a huge opportunity for circular materials and systems, but you truly need a system and many partners working together. Altogether, our circular economy program has three elements. One being circular feedstock, second being new material cycles, and the third one entirely new business models. For example, also leveraging on digital solutions next to the product cycle. These are living examples of a broad range of topics. So we are not just focusing on carbon, but you see a rather broad range of topics. It takes us working together. So I'm glad to have so many partners actually joining for this event series. We will host a session that will focus on how packaging designers and label designers are working across the recycling supply chain to improve the recyclability of their products by design. Please tune into these sessions on circularity. Now, coming back one more time to renewable energy. A core component in reducing our greenhouse gas emissions, actually also on a short note, is the gradual conversion of energy supply from fossil to renewable sources as part of our carbon management. So our electricity requirements will actually increase by means of further electrification of processes in the coming years. And that alone will also increase the challenge. So here we aim to source more than 60% of our power needs from renewable sources by the year 2030. So based on our forecast, this is roughly the equivalent to our total power demand back in the year 2021. Renewable energy is something that we drive globally, but also in different ways. For example, in Asia, we build that in whenever we build a new site. In Europe, we took decisions, as you saw it in the opening video, on make cases, so going into renewable energy production directly. In the US, a lot has been done already, as also visible in our corporate report. For example, on the example of the site in Freeport, that's one of our largest production sites worldwide, as its entire energy demand nowadays or will be covered by renewable sources already contracted. So you will hear also about a floating solar project in our McIntosh, Alabama site, as we evaluate innovative ways to add more in renewable energy to our mix. But we don't have all the answers or technology that we need, and investment in startup companies will help pave the way to incubate novel technologies that we need to solve our climate challenges. And that's the perfect segue to actually now introduce and hand over to our first panel and fireside chat, but who's better prepared than Irene Yang to do so? Irene, hand it over to you.
Thank you, Tobias, and welcome everyone to today's fireside chat with Breakthrough Energy Ventures. Groundbreaking technologies, often from startups, are key to achieve net zero. We in the chemical industry could partner with or potentially invest in startups as well. Our honored guest today, Dr. Eric Thun, is the managing partner and CTO of Breakthrough Energy Ventures. Founded by Bill Gates, Breakthrough has raised over $2 billion in capital to support cutting-edge companies, leading the world to net zero emissions. Eric serves on the investment committee at Breakthrough and is responsible for overall technical direction, from thesis development to technical diligence. And Eric, you certainly know your chemistry. A member of the Faculty of Chemistry at Duke University and former director of DOE's Advanced Research Program Agency, or as we all know it here in the US, ARPA-E. Eric trained as a bioorganic and physical organic chemist, authored 300 original papers and abstracts, served as vice provost and director of Duke University's Innovation and Entrepreneurship Initiative, is an inventor on over 30 patents, and founder of 3 venture-backed pharmaceutical companies. Hosting today's fireside chat is BSF Venture Capital's managing director, Marcus Olabita. We at BSF also invest in disruptive startups who bring new technologies and business models to the chemical industry. We're honored to have Eric with us today to share his thought leadership on net zero. I encourage you in the audience to type in your Q&A, as there might be time near the end of the fireside chat to address some of your questions. Now I'll turn it over to Marcus to begin our discussion.
Yeah, thank you very much, Irene, for the kind introduction. And hello, Eric. Good to see you again. Yeah, looking forward to our conversation. So Irene already mentioned you're with Breakthrough Energy Ventures. I think most in the audience are aware that a very highly respected deep tech and climate tech investor, and who has been around for a while. And but maybe to get started, Eric, you want to say a few words about the investment focus and the investment criteria of Breakthrough Energy Ventures. What are you looking at? What kind of investments are you targeting? And then we take it from there.
Well, thank you, Marcus, and thank you, Irene, and everyone at BASF for giving me the opportunity to come and spend some time with you today and to talk a little bit about what we're thinking about at BEV and where we see the world going. So as Irene said, Breakthrough was stood up really in 2016, began investing in 2017. We are charged with investing in all areas responsible for the production of anthropogenic greenhouse gases. So even though we're called Breakthrough Energy Ventures, our purview is a little broader than that. We'll invest in, we sort of bin the world into 5 areas that we invest in: electricity, transportation, buildings, manufacturing, and agriculture. So those are all of the areas that are responsible for the production of greenhouse gases, all areas that we are active in. We look at a number of criteria when we consider an investment. Obviously, technical feasibility is at the top of the list, and we have assembled, I think, an unusual group of people at Breakthrough who are well trained to evaluate these programs from a technical perspective. We had to set some sort of a threshold for the impact component of what we do, for the consequence in greenhouse gas production that is available to a particular technology. And what we did was we said 0.5 gigaton. So we will invest in technologies that we believe have entitlement to mitigate at least 0.5 gigaton per year of CO2 equivalent greenhouse gases. That's about 1% of annual emissions, right? So the idea is we're going after big opportunities. Now, of course, what happens next is everybody shows up and their technology will mitigate at least 0.56 gigatons per year of greenhouse gases. It's never 0.5, it's always 0.56. And so usually what I tell people is, we want 0.5 gigaton, and if you need a spreadsheet to show me how you get there, don't bother. The idea is we're supposed to be going after the biggest, hairiest problems that we can possibly find. We're looking to attract new investors to the field. That's less of a challenge now than it was when we began investing in 2017, but we certainly want to broaden the base of capital that's available to support and advance these technologies. And we also want to invest in areas that other people aren't investing in. If there's 10 people fighting to get into a deal, that's probably not a space for us. So those are the criteria that we look at when we consider an investment.
Yeah, thank you very much, Eric. Very helpful, and of course it's sounds very ambitious. But I understand that, of course, you want to be selective. These days, we see a lot of deal flow from the clean tech and climate tech space, and of course, if you don't claim that you mitigate climate change with your business model, then you're out anyhow. But of course, to test for the real significant impact, of course, is an interesting and an important stage gate, I would say. So Eric, you have been around for a while in the industry, and the chemical industry, also as an investor. Even before Breakthrough Energy Ventures started, of course, we jointly, BASF, and you also personally, you looked at investments in the clean tech space. Today it's called the Clean Tech 1.0. that happened maybe in the years 2005 to 2008. And nowadays we're talking about clean tech 2.0, where there's a lot of interest in the industry, a lot of attention for the sector, many first-time funds, a lot of capital allocated. So if you look back to the period 16, 18 years ago and where we are today, what are your takeaways? How can clean tech 2.0 be more successful than the obvious not so successful clean tech 1 boom and investments have been?
I think it's a really great question, Marcus, and it's always important to try and learn from the past. As you mentioned, somewhere between 25 and $50 billion disappeared down rat holes in clean tech 1.0 as the venture community tried to just simply map clean tech onto tech. And I think that there is a large number of important differences between tough tech broadly, but clean tech specifically, and tech that make venture a challenging model for this space. The first is just the timelines. Timelines for a traditional VC fund are 10 years, but we know that impactful development and deployment of technology in the tough tech space takes often longer than 10 years. So just starting with something as simple as the length of the fund. And so Breakthrough has moved to a model where we use 20-year funds that we feel is a more realistic timeline for the deployment of these technologies. We need a very different group of people involved in making decisions and evaluating technologies and looking at in making decisions in these spaces. You know, if we think about how tech works, if we're honest about how tech works, I look at 50 different opportunities. 43 of those, I say, I'm pretty sure those aren't going to work. The other 7, I don't know, you know, maybe. So let's give them a little bit of time and a little bit of money. And that model works fine when a little bit of time is 6 months or a year and a little bit of money is $500,000. The problem is when you come to tough tech and to clean tech, now all of a sudden a little bit of time is 5 years and a little bit of money is $30 million. And so, you know, the idea that you can seed an enormous number of things with small checks and short times and see what happens, it just doesn't work in this space. And so you need a very different group of people. I would posit that we have assembled the most technical group of people that's ever been assembled in a venture firm at Breakthrough Energy because we very much believe, you know, in that theory. There's also the issue of how things scale. When you work in, you know, the sorts of innovations that we are developing and hope to deploy in clean tech scale very differently than apps and cell phones. And so, you know, there's still this issue that you fight and you work and you raise money and you raise $200 million or $300 million and you say, success, we got it. It works technically. And I have some idea of what the cost entitlement is. Well, but now I need $800 million to build my first plant. Where does that money come from, right? And so the idea that we didn't think about the valleys of death, which are very, very different, much deeper and much longer in these spaces than they are in areas like tech. Another failure. And so we have built a number of other devices. We have a fund that we're calling Select, that's a scaling fund. We have a separate enterprise called Catalyst that seeks to do project development. You know, all of these kinds of things to ease these technologies over the valleys of death and towards impactful deployment. And then the other piece is we have to remember that energy is probably the most highly regulated market on earth. And so thinking that you can do deployment successfully in this space without having a public affairs group that's very actively working with regulators, that's working with lawmakers to help them understand how these technologies work and make sure that there's a landscape that's ready for the deployment of these technologies. All of those kinds of things are incredibly important, and all of those things were overlooked in Clean Tech 1.0. So Clean Tech 2.0, we're certainly doing an experiment. We're going to find out if it's the right way to do things or not. But But nothing changes if nothing changes, and so we've certainly made a number of changes.
Thank you, Eric. And interesting statement that you are making here. You many things that didn't work in cleantech 1.0, and I still remember at that time there was usually a business model and a business plan behind it, where it would be kind of okayish in terms of return, but then everyone would say, but on top we will earn these carbon credits, which of course in 2005, 2006 were non-existent. And but there was hope that soon there would be another government in the United States, and there would be globally around then the Paris Agreement later on, there would be also move towards CO2 price. So there was a lot of optimism around a green premium being paid for, let's say, the products that came out of these new business models, which of course, as we know as of today, were never paid. Today, we are more optimistic. I think in terms of the demand side, we are much better off. There is a demand for green products, certainly. Many corporates have announced, and governments have announced very ambitious goals. But how do you see the topic of the green premium? Is it, do we have it? And starting probably with the price for CO2 and the adequate pricing of CO2, where opinions are quite diverse. What is the right price for a ton of CO2? Do you have a take on that?
Yeah, this is one, it's another really great question, Marcus, and one that I've been scratching my head a great deal about. Green premiums in some instances are still significant. I think it's important to remember that there are green premiums that are negative, right? Where we can achieve an equivalent service carbon-free for less than we can today. Many of those are in efficiency, things like LED lighting and new heat pumps, but also new approaches to ammonia and fertilizer. So there are things that have a negative green premium, but of course, most things still have a positive green premium. That is, they cost more per unit in a carbon-free format than they do in the business as usual case. And thinking about what the relevant green premium is very important. I think it's super important to remember that the premium on a commodity is not the same as the premium on a service. So, ethylene, in zero carbon format perhaps costs $500 a ton more than business as usual ethylene. But by the time I get around to a bag, it costs perhaps, a tenth of a cent. So it's important to keep those two things square in your mind. We have sort of drawn a line in the sand of $100 a ton for things like carbon capture. And we set those price targets for a complicated set of reasons. They seem technically challenging. If you look at the cost of $100 a ton of carbon applied to even things like gasoline and diesel, $100 a ton on gasoline, carbon price on gasoline adds about 90 cents to the cost of a gallon of gasoline. It's, are people willing to pay that? I think the challenge that you have is that there's really no evidence that there's any sort of societal willingness to pay anywhere even close to $100 a ton. And there's a whole there's a whole social science literature out there where folks have devised really quite clever experiments to understand better what people really are willing to pay for the cost of carbon. And it's a lot less than $100 a ton. It's probably more in the vicinity of $10 a ton. And that makes things very, very difficult and leaves you kind of scratching your head about what you might do. There are, of course, very, very, very low cost approaches to doing carbon capture. We can do carbon capture by iron fertilization of the ocean for probably $1 a ton. But is that really something that we want to do? So there's a set of very difficult societal questions that need to be answered. People like myself, I think people like you, we're techno-optimists. I think that our job or what we're trying to do is to provide society a palette of opportunities that they can, from which they can make choices. But people are going to have to make difficult choices about exactly what a ton of CO2 is worth. And there's not a straightforward answer to that question.
Yeah. Yeah, which leads me to another, let's say, current topic up to date. I would like to discuss with you, and I wonder just what you, Eric, think about us Europeans. We have a remarkable weekend behind us, where in Germany the last 3 nuclear power stations were turned off. But this was also the weekend where in Finland, the most modern and most powerful nuclear power station of Europe went into operation. So this is the news from last weekend. And of course, we looking at Germany, there's a lot of excitement in politics around hydrogen, green hydrogen, of course. So the assumption is that green hydrogen will solve basically everything in our, let's say, all energy problems that might come up. And so I wonder how you see that, and what kind of advice you would give to German politicians from your perspective, or to Europeans. What's your take on a, let's say, on a realistic energy mix moving forward? And what are the components from your perspective that are important and should play a role?
Boy, there's an awful lot in that, Marcus, but it's a great question. Let's start with the issue of the grid. It has certainly become popular in a lot of circles to imagine that the solution to our carbon situation is to decarbonize the grid by putting enormous quantities of zero carbon electricity onto the grid, and then to decarbonize everything, right? I think there are 2 important caveats that people need to remember when they consider that perspective. The first is around the issue of cost. So when people talk about a cost-effective, electrified alternative to a business as usual strategy, they often make, I think, unrealistic assumptions about the cost of electricity. If you look to the marketplace today, you can see that people are signing PPAs for $10 a megawatt hour, $15 a megawatt hour. And so people plug a penny a kilowatt hour or 1.5 cents a kilowatt hour into an equation and say, poof, it works, right? It's important to remember that that carbon is that very low cost electricity is probably not grid connected, and it is certainly intermittent. And so the process that you are imagining needs to be consistent with intermittent electricity. If it needs to be firm electricity, then you're going to have to involve storage to firm that electricity. And if you have to involve storage to firm the electricity so that you can run your process 24/7, now that electricity doesn't cost a penny or a penny and a half a kilowatt hour. Now it costs more like $60 or $70 a megawatt hour. And you need to make sure your math still works with those levels for electricity prices. So that's the first piece of this that's important. The second surrounds the operability of the grid. You have to remember that this very low cost electricity, this wind and solar, is intermittent. There are limits to the amount of intermittent power that you can put on a grid and maintain stability. Grids go down, they become unstable if the frequency varies very far from 60 hertz. And when they go down, they stay down for long times. They stay down for days or for weeks. And so there is an enormous need for zero carbon baseload power. Now, you can certainly take intermittent energy and firm it, but remember that some of those intermittencies have time constants of months. And so there's a limit to what you can do for firming electricity cost effectively with storage. We absolutely need baseload generation. If you're going to take coal, oil, and natural gas out of the equation for baseload generation, you don't have very much left to work with. You have things like hydro, which at this point has mostly been built out to the extent that it can. There's certainly work to be done in things like low-head hydro, run-of-river hydro, powering unpowered dams, things like that, but there's not a lot of large-scale hydro left to build out. There's geothermal, which again is limited. Conventional resource, even in the United States, is limited to about 50 gigawatts. And unconventional increases that maybe 10x. But you've got to have the right geography, right? You've got to have heat that's close to the surface. So there's a limit with what you can do there. Things like wave and ocean current energy, perhaps someday, but not today. And so really for baseload generation, you're left with nuclear. Now, nuclear can be divided into fission and fusion. Fission, the amount of fission on the grid, at least in the United States, has been about constant or maybe even declining slightly over the last several decades. That is because of cost. The reason that nuclear is not deployed more extensively than it is today is because it's just too expensive. And that expense traces directly back to 3 Mile Island. So if you look at the decades after 3 Mile Island, you saw the cost of nuclear energy per kilowatt hour increase by 3-fold, 4-fold, 5-fold. And so nuclear fission by today is just not cost competitive. We at Breakthrough believe that the reason it's not cost competitive is because you're stuck in a paradox that nuclear fission is inherently dangerous. You have issues of waste, proliferation, and safety from uncontrolled or runaway reactions. Those are inherent to the technology. There is no way to get rid of them. And so because nuclear is inherently dangerous, it's inherently expensive. Instead, we have invested really quite heavily in nuclear fusion. And nuclear fusion avoids all three of those problems. Yes, there are wastes, but those isotopes decompose over decades rather than millennia. There's no issues with proliferation, and runaway reactions aren't possible. Now, that doesn't mean that fusion is going to be cheap. It certainly doesn't mean that it's going to be cheap, and I don't want to imply that we know that it is. But you're not stuck in the paradox, so we feel that there's at least an opportunity for it to be cheap. And that's why we have invested in things like Commonwealth fusion and Type 1, and in a number of other approaches to nuclear fusion. But back to your high-level question, there simply is no way to operate grids at the levels that they need to be. Remember, electrify everything implies increasing the size of the grid by probably 4-fold. How you do that and maintain a stable grid without base load power I personally don't believe that there is a way to do that. And there are pretty significant limits on what you can do for base load power. So that's kind of my feeling on the grid and on electricity.
Yeah.
Would you like to talk about hydrogen as well?
Yeah, that of course would be the next topic, but the grid already, it's what you're mentioning. I think not many politicians really imagine what it takes if you say, well, we want to electrify, basically the whole car fleet. And that's of course a target in Europe and maybe a little bit later in the United States as well. At the same time, we want to electrify the whole chemical industry and all the steel industry and the production here. What that really requires, I think, is beyond the imagination of politicians who decide today, say, we can do and turn off another nuclear power station and still the grid holds. So apparently we did the right thing. So this is a little bit how it appears here in Europe. But addressing the topic of hydrogen, I mentioned it before. There's a lot talking about, let's say, vision and excitement that we also have for the energy space. There's a lot of excitement around green hydrogen, of course, and many, and of course, being affected by the war between Russia and Ukraine. And the question, how do we replace LNG, that even accelerated the, let's say, ambitions and the move towards green hydrogen. But green hydrogen, of course, can be many things. It can be a replacement of gray hydrogen, which is still very abundant and I think 160 million tons a year produced around the globe. So probably makes sense, makes a lot of sense to replace the gray hydrogen with green hydrogen as a first step. But then, of course, there are many plans to put green hydrogen into planes, into cars, into trucks, into buses, and so on. I wonder how you think about that. Is green hydrogen the solution, or do we have to put a few question marks behind it, Eric?
Well, like everything else in energy, the question comes down to cost. The question comes down to cost and for how much can you produce that green hydrogen. And you do have to make sure that your hydrogen is actually green. If you're making hydrogen by electrolysis using electricity that was generated by coal, oil, and natural gas, you don't have green hydrogen. So electrolysis doesn't somehow magically make hydrogen green. Now it depends on at what cost can you do this? You're somewhere in the low 50 kilowatt hours per kilogram of hydrogen that you're going to make. So if you're paying 2 cents a kilowatt hour for your electricity, you're $1 a kilogram before you do anything else. And if you're going to have 2 cent a kilowatt hour electricity, as I mentioned, it's going to be intermittent. It's not going to be grid connected, and it's going to be intermittent. So your approach has to be compatible with intermittent electricity, which probably means PEM electrolysis. PEM electrolyzers today, as you know, are over $1,000 a kilowatt. And there's no way you're going to get anywhere close to $2 a kilogram for hydrogen. If you're paying $1,000 a kilowatt for your electrolyzers. So is it possible to make electrolyzers for, say, $200 a kilowatt? I don't know, but that we definitely need that. And then we need enormous amounts of zero carbon electricity. Hydrogen is sort of the Swiss Army knife of energy, right? Hydrogen is pure reactive chemical energy. If you have enough hydrogen and it's cheap enough, you can do anything. You can do absolutely anything. You can make liquid fuels. You can make chemicals. You can make fertilizer. You can make steel. You can make food. If you have enough hydrogen and it's cheap enough, you can do anything. So the question is, how far down that cost curve can you go? I think we discussed the issues with electrolytic hydrogen. I will tell you that the one that I am most excited about today is geologic hydrogen, right? So this is not long after the turn of the century in Mali in North Africa, they were drilling a well for water. They went down a few hundred meters and the well exploded. They assumed that they had drilled into natural gas. They sealed up the well. They went back in 2014 and opened it to start extracting the natural gas. And after a very short period of time said, hey, wait a minute, this isn't hydrogen, or this isn't natural gas, this is hydrogen. By now, it seems that there are a number of places around the world where hydrogen comes up out of the ground on its own. There's enormous amounts that leak out just through the mid-Atlantic rift, but there are a number of places in the continental United States, in Australia, in Africa, perhaps in Europe, where hydrogen can be drilled out of the ground. We believe the ultimate source of that hydrogen is the reaction of iron 2 with water, which makes that source of hydrogen effectively inexhaustible. We believe that some of that hydrogen may have a lifting cost of significantly less than $1 a kilogram. So, the idea that there may be an enormous source of geologic hydrogen that is absolutely green is one that I find incredibly exciting, and I feel could be one of the biggest transformations this planet has ever seen with regards to energy.
Oh, that's very interesting topic, and I just learned about it from our conversation, Eric. So that's very interesting, and of course also a source of optimism and to explore further. And what you mentioned before, making electrolysis more efficient, of course. We at BASF Venture Capital would be looking forward to partner with you in the right companies to make that happen, right? So I think we are currently in fruitful discussions here. Which leads me to another topic. And we have in the audience, of course, many chemists, many employees of BASF, people also from the chemical industry, and of course you are extremely familiar with it. And but the chemical industry today, of course, for the last decades has been based on petrochemical feedstock. And the discussion today, of course, is talking about scope 1 and scope 2, electrification of our production. Yes, that's one step, but then scope 3 is what is the appropriate feedstock, and how is it possible to replace our beloved petrochemical feedstock that we got used to over the last decades. Is it possible at all to find alternative feedstock in, let's say, significant amounts? And you know that BASF is fully integrated chemical company. We care for the base chemicals as we do for the intermediaries and the specialty chemicals. So we talk about serious volumes at BASF. And so what's your take here? Is it possible to replace raw oil or naphtha as a feedstock in a foreseeable future? Is it worth it all to try, or should we give up and look for other areas of activity because the task is just too big? What's your take on that?
We can't do that, Marcus. We can't possibly do that. We have to be, we got to be the optimists out there.
Yeah.
Yes, so I do think it's possible to move away from those fossil feedstocks and towards green feedstocks. You say in a realistic period of time there, I think we could have a conversation about what you mean. But let's think about exactly what it means. I would argue that if you have green hydrogen and green CO2 so that you can make green syngas, you can make pretty much anything from that, right? You guys are the chemists, and you guys know industrial chemistry better than I do. But my sort of as an academic chemist's belief is that if you have green syngas, you can make pretty much anything from there, right? You can make ethylene, you can make hydrocarbons, you can make pretty much anything. So how do you get to green CO2 and how do you get to green hydrogen over a relatively short period of time? Meaning, let's say a decade. I think we just talked about green hydrogen. I think that the combination of very cheap intermittent renewables and low cost PEM electrolyzers is one route that could get you at least close to $2 a kilogram for hydrogen. I think that geologic hydrogen, if that pans out and goes, could get us below $1 a kilogram for hydrogen. So then you're left with CO2. The first source of green CO2 that I think that we turn to is the CO2 that comes off of ethanol facilities, right? In this country, in the United States, 1/4 of all US cropland is planted with corn, and 40% of that corn is used to make biofuels. That's a lot of CO2. 2 out of every 6 carbons from every one of those glucose molecules ends up as CO2. And that is beverage quality CO2. It's wet, which isn't helpful for the chemical industry, but it is, there is no sulfur, there is no anything, right? So, when you think about it, just back of the envelope, Marcus, there are two pretty large sources of green hydrogen and green CO2 right off the bat that effectively are ready to go today, right? If we go a step beyond that and think about where does this CO2 come from, there's a number of air capture facilities that are being built now by firms like Carbon Engineering, firms like Climeworks. Do those generate cost-effective CO2 yet? No, they don't. There's still, it's hard to get real numbers, but somewhere close to $1,000 a ton. Do we think that those or other technologies that are being developed could get to $100 a ton? We do. And like I say, at $100 a ton, even on gasoline, that adds 90 cents a gallon to the cost of gasoline. So I think hydrogen and green CO2 off of ethanol from corn, from photosynthesis, that's ready to go pretty much anytime we want. And of course, cane in Brazil. And I think that larger sources of carbon come online over a period of time. So yes, I am absolutely optimistic about it.
Oh, great!
Marcus,
great to hear that. So I think this is a good moment to check for questions from the audience, because we said we want to finish our session also by taking questions from the audience. So Josh, has there been questions in the chat? And if so, yes, please read them out and let us know how we can answer questions from the audience.
Absolutely, there've been a tremendous amount. So we'll get to a couple, and thank you for everybody that submitted them. So this one's going to go to Eric, but I think I would also welcome Marcus to answer as well. Eric, as a regular investor in clean tech, what would you say is the biggest threat to an upcoming clean tech startup?
The biggest threat to an upcoming clean tech startup. Oof. There are myriad. There are certainly, there's certainly a lot of dollars around. Even the chill in clean tech in investing generally that's happened over the past little while. There is still pretty reasonable activity in the clean tech sector. I think that you are always concerned about an uncertain future cost of the business as usual case. Right? Trying to draw a line from where you are now to where you will be at your ultimate deployment, and how that is going to compare. You've got multiple moving pieces here. And so figuring out what the relevant price target is a very difficult thing to do. Thinking about scale, and thinking about scale from the very, very, very beginning is something that startups absolutely positively have to do. And if there is a way that you can think about scaling by what we call numbering up versus scaling up, we think that's very important. So if you compare, we were just talking about carbon capture, for instance, Climeworks versus Carbon Engineering, both great companies, incredible people running them, love everything about both of them. But the Climeworks box is a box that's a few meters on a side and costs $10,000 or so to build. And so when I scale that, I'm going to scale it by numbering, and that is much cheaper than Carbon Engineering, who are currently building their first facility in the Permian, and that's going to cost over $1 billion. And so when you ask those guys and say, how long till you know your ultimate cost entitlement? And they say, well, probably by the 6th or so plant. You sort of sit there and scratch your head and say, okay, so I got to come up with $7 billion to figure out what your cost entitlement is. So thinking about how you're going to scale at the very beginning is something that I would encourage people to do. Those are a couple just off the top of my head. I'm sure Marcus has wonderful thoughts as well.
I just would have, a more, let's say, cynical or philosophical answer to that. What is the biggest threat? I think my answer would be, the biggest threat would be to take a successful fundraising round as a proof of your business model. Right? And so don't forget what is actually the ultimate goal of your company, what you want to try to achieve. And a successful financing round is not, of course, you have to celebrate it if you have it, but like an IPO, it's just an intermediate step to achieving your actual goals.
Great, thank you both. Another question that's come in, very good questions, and kind of aligned with, we were discussing technology, talking about the role that government can or maybe isn't playing. But what about the role of shareholders? So the question is there a need for shareholders to push companies to adopt carbon reduction strategies? Things like investment funds saying we're not going to be participating in companies that have poor policies around carbon reduction. So welcome either of you, but maybe we start again with Eric.
Well, I think the obvious answer to that question is yes. I think the harder part is thinking about in exactly what format. And what I would encourage investors to do is to avoid being reactionary, to make sure that you're educated, to make sure that you're realistic, to remember that there aren't parallels between energy, big energy, and big tobacco. You can't just wish this away. And so I would encourage investors to certainly be activists by all means, but to make sure that you're educated, to make sure that you're realistic, and to make sure that the changes that you're advocating for are actually going to move us in the right direction.
Yeah, I can only confirm and share the view of Eric. I mean, we as private investors, private companies, of course, we have ideas and we have principles and we have goals that we communicate, but only if we can help our portfolio companies with specific ideas, with our resources, with our input to achieve these goals, then I think we are credible. Just to stand up and to say you have to do this and you have until 2030 and that's it, probably will not do it, right? And but that's somehow happening. So yeah, I would completely agree with Eric to go for the feasible goals, for the realistic goals, and that's very important. And take a very active role as a shareholder in terms of support and engagement.
Thank you both. We're going to do one more quick one because I know we're running low on time, but I want to end with something that's a little bit more technical. And based on Eric, your comment about geologic hydrogen, which it's already been clear that that's some new news to us, which is pretty exciting. There's a technical question. Are there environmental concerns with drilling for hydrogen?
Yes, unquestionably. and you know, but this brings up another great point. You know, the one of the hardest things there is to do in the whole energy game is to wrap your head around scale. There is almost no way for humans to understand the scale at which we do energy. If we had more time, I have a whole bunch of interesting little stories that I could take people through to try and help understand the scale. So the first thing that you've got to remember is that we do energy at scales that dwarf any other human activity. There is no way that you can do things at those scales and insist that there be no environmental consequences, because that means you will do nothing. And so you absolutely have to accept that any of the things that we are talking about here are going to have environmental consequences. We can work to minimize those, but there are going to be consequences. The primary concern with drilling for hydrogen is that hydrogen is an indirect greenhouse gas. It traps hydroxyl radicals, it destroys hydroxyl radicals. Hydroxyl radicals are the primary mechanism by which methane is destroyed in the atmosphere. And so, you know, depending on how you look at it, hydrogen too is a greenhouse gas. But most of the issues around drilling and leaking and things like that are just hygiene issues. You know, you can insist that people that people take care and don't leak. There's no real technical issues that need to be addressed. So, you know, will there be environmental consequences of hydrogen drilling? Absolutely, positively. Are they less than continuing to burn oil, coal, and natural gas? Yes, absolutely. And so we should pursue them, but we should be careful and responsible.
All right. I think with that, I'll jump back in.
Yeah, thank you, Mark. Let me thank Eric for this great conversation, and that was extremely insightful. And I think we are both sharing the optimism that technology and chemistry can be a solution to many topics that we discussed today. And so that, of course, motivates us in what we are doing as investors, but also as chemists and as co-workers of BASF. So I think we have a great alignment here, and thank you very much, Eric, for being around today.
And thank you. I thoroughly enjoyed it.
Very good. So I will echo what Marcus said, and thank you, Eric, for participating today. I'm glad that hydrogen came up as a topic. I know it's something that that is important. It's broader and broader. A lot of people are talking about it. I think there are some very good questions that we were asking today. I think the discussion on the grid was also very interesting. We talk about renewable energy, but oftentimes the grid is a separate discussion. I do think that both of those go hand in hand. So first of all, thank you to our speakers for participating today. Your time, I know, is valuable. I know schedules are tight. You were able to make this work and all the preparation that went into it. So very much appreciate your dedication to sustainability and to being here today. Also, thank you to our audience for participating, for tuning in. Thank you to all. I think that concludes our morning session. I would invite everyone to join our afternoon session, which is coming up in about an hour. These sessions are pre-recorded and will be available on demand through this particular platform. So you'll be able to access the recordings sometime afterwards. There's a certain period of time and then they will be available. So please don't forget to check back with us on that. And with that, thank you all and make it a safe and sustainable day.
Thank you very much. Thank you for the opportunity. Bye-bye.